Alright, hello friends. So this is an exciting moment or a sad day depending on how you want to think about it, but this is going to be the last lecture, the last programming lecture done entirely in Scratch, okay? So just let that sink in. We are ready to graduate. We're ready to move on after this. But we will talk about program creation and then we'll finish up Scratch, and that'll be that. Alright, so moving on. Let's talk about the program creation process. Let's spell it all out so that we know exactly what's going to happen, or what needs to happen when we write a program. So here it is. So if you want to write a correct program to do something, to perform some task, you have to have knowledge of at least these three things. You need to know about the problem itself, of course. You need to know what needs to happen, what you're going to do. Like, I don't know, you have to know all the concepts involved. Maybe there's math or something that you need to brush up on, something like that. And so you definitely need to understand the problem or spend some time thinking about it. And then finally, the two very important things are how the program is going to operate. So most programs do something different depending on user input. So you're going to need to figure out what kind of input the user is going to give you, and then what you're supposed to do with it. So what will the user give you, if anything? So we've asked the user, hey, do you believe in ghosts? And that is, we're asking them to enter in a yes or no answer, to enter in some characters, or maybe we want the user to enter in their favorite number, and we'll print it back out for them. So have an idea of what the user is going to give us, and we'll use that to then go and solve our problem, and that could be written better. There. And then outputs is what are you going to do with those inputs? So you're going to take the inputs, solve the problem, and then produce some output to the user that holds what they were looking for, right? So what are you going to do with those inputs? What's the answer that your program provides? Back to the user. So that's a question you need to think about, and sometimes it's not a normal thing. Like maybe part of your output is moving the ball and having the paddle move based on keyboard input. Part of your output is having the ball bounce off the little paddle. Okay, so outputs can come in all different shapes, but your program is solving some kind of problem given inputs. They could be keyboard inputs. They don't have to be things typed in. They don't have to be yes or no. They don't have to be a number. They can be the up arrow. That could be an input. And then the outputs are whatever your program does with those inputs, okay? And provides some kind of useful utility to the user, okay? And so it's your job to think about these things long and hard and then come up with some kind of strategy that will take the inputs to the outputs. That's how I want to say it. So you start with the inputs and you bring them to the outputs. You somehow make the correct outputs based on the inputs, okay? There's a million different ways to say it, and that is in essence the process that you need to follow whenever you write a program. Because you can't just start writing code and expect that you'll eventually get to the right place. Okay? That's all. So let's do a couple examples and really think it through. Okay, so the first one is calculate N Factorial, where N is user input. Okay, so we immediately know that the input is a number. Okay? Alright. And what is the output? Well, imagining we'll somehow display the answer, maybe we'll print back N Factorial. We'll also have the output be a number. And so, okay, the problem is taking one number and finding the factorial of that number, okay? And there can be little subproblems. And this is exactly what I want you to be thinking about. what are some smaller issues that might happen and might need to be taken care of? Subproblem. So perhaps the user entered a negative number, and there is no factorial of a negative number, at least according to the normal definition of factorials. So that's undefined. How are you going to deal with that? Maybe you should output an error message. But that's your job as a programmer to figure out, well, if things go wrong, how do I deal with them? Okay, so that's part of the problem. And then you have your main problem. At least this one seems like the main problem to me. It's taking that number and finding the factorial. So how do we break down and compute a factorial? So my idea, and you can come up with your own idea, the standard way that I think I might do it is I'm going to get the n from the user, I'm going to put it in a box. All right, so maybe it's 5. And then I'm going to make an answer variable for myself, make my own little box, and work with that. I'm going to put the answer in here, and I'm going to eventually have it hold 5 times 4 times 3 times 2 times 1, right, because that's the factorial. But the answer needs to start somewhere. And I think because I'm going to be multiplying things, I'll start the answer at 1, so that whenever I multiply something, it'll just become that new thing. Okay? So maybe that's how I'll do this program. 2 variables, n itself, and answer. And maybe I'll keep multiplying n into answer and decrementing n. And this wouldn't always work, depending on what your answer needs to be. Maybe you need to save n for later, but I'm just going to make n eventually smaller and smaller and smaller, and then I know when I'm done. Once n is, let's say, 0, stop and output the answer. So that's my algorithm that I came up with. Okay? And that's a strategy. So you can think of strategy as algorithm. Okay, just a sequence of steps that solves the problem that we were trying to work on. Okay, so this is my idea. I'm going to have these 2 variables. One I'll get from the user through the input, and then I'm going to have an output that I'll give back to the user, and I'll call that answer. All right. Dun dun dun. Or maybe just to not confuse us with what Scratch does, I'll call this out for output. Scratch does take up some special variable names for itself. Okay, so if n was 5, and I follow this process, I need to figure out if it works. So I can try it on a bunch of inputs myself, and that's usually the best idea. So let's pretend that the user entered 5 and we have it, and let's try and build up the correct answer inside of out. So I'm going to follow this process. Keep multiplying n into the answer and decrementing n. Okay? So multiply it into the answer, so out equals out times 5 now. So it's going to be 1 times 5 or 5. And then I'm going to decrement n, so it becomes 1 less. Now it's 4. All right, and I'm going to keep on doing that until n is 0. 4 times 5, 20. 4 minus 1, 3. 20 times 3, 60. 3 minus 1, 2. 2 times 60, 120. 2 minus 1 is 1. 1 times 120 is still 120, so we could have stopped here, but why not go further? 1 minus 1 is 0, and we are done. Okay? And so the answer that we give back to the user is 120 is your answer. That is the factorial that you were looking for. Okay? So I encourage you to play around with this, try some more examples, understand why it might work, and maybe code it in Scratch. That would be a great exercise for you, I think. Okay, but that is an idea, or that's just an example of this whole program creation process. All right, let's do it again. So now, this time, let's take two numbers that are both user input, and we're going to sum the numbers from n1 to n2. So if n1 happened to be 2 and n2 happened to be 7, we're going to sum the numbers. We're going to give back to the user 2 plus 3 plus 4 plus 5 plus 6 plus 7. So all the numbers in between, just like that. Okay? So what are our inputs? And I encourage you to pause this, write up your own answers. We actually have two this time, n1 and n2. What kinds of inputs are they? They're numbers. Okay? All right. You can get a bit more fancy, and we'll get fancier later with types of things. They happen to be whole numbers, specifically. And then, what are our outputs? Well, it's just one thing. It's the sum. So, which is a number. So we get two numbers, we give back a number. Okay? Then, all right, following our process, well, what's the actual problem we're trying to solve? Summing those two numbers. And so I guess we'll do the same thing as this. And again, there can be subproblems. Maybe the user gave n1 that was greater than n2. You just be like, hey user, give me another value. And you keep on asking the user for a valid set of two numbers. Or maybe you just stop the program and say, hey user, you're silly. Why would you do that? Whatever. That's up to you. That's your job as a programmer, is to solve this problem in a way that makes sense. Okay? And limits the amount of errors that happen. And then you have your main problem. So how are you going to keep track of summing those numbers? Okay? Actually doing the sum. So we have n1, we get that from the user. We have n2, we get that from the user. I think we should follow the same pattern and have an output variable that will hold the sum. We can call it sum. I'll just call it out again. And we're going to keep on adding stuff into out. Yes? Instead of multiplying stuff into out. So I think out, to correctly reflect what we put in it, should start at 0. You see that? How when you're adding stuff, you start an accumulator variable at 0, and when you're multiplying stuff, you start an accumulator variable at 1. So this is called accumulation. 1 when multiplying. Let me, oops. Start at 0 when adding. Okay? And then you can make similar concepts for division and subtraction. Probably 1 and 0 again. Okay, so that's the idea. So I'm going to need these things. Definitely going to need an output variable. It starts at 0. I guess I don't need that comma. And I'm going to need to somehow go between n1 and n2 and put numbers into out. So maybe, assuming we don't need n1 or n2 ever again, I can use n1 and keep on adding n1 into out while it is still less than or equal to n2. Okay? That was a big concept in a short sentence, so let's talk about that. So yeah, that's the idea. This means less than or equal to. Okay? So n1 is less than or equal to n2 at the moment. I will add n1 into out. So it becomes 2. Okay, and I really encourage you to code this up in Scratch. Let's see here. Then we're going to increment N1 to get to the next number that we need to add into it. Okay? So now I've done my adding of N1, my current N1. Let me change it now to be one more and add that into out. Okay, we're going to keep on doing that until we're greater than N2. Alright, so 2 plus 3 is 5, and increment N1 to 4. Okay, so it's always add N1 into out while it's less than or equal to N2, and then increment N1. So this is a loop. Add 5 to 4, so this becomes 9, and then we add one more. Add 5 to 9, becomes 14, add one more. Add 6 to 14, becomes 20. Now we have 7. Add 7 to 20, now we have 27, and this becomes 8. And finally now it's not true that 8 is less than or equal to 7, and so we stop. And the output, the final output, is 27, and hopefully I did my math right. You can yell at me later if I didn't. So, again, we were very methodical here. So there is a bit of magic that goes on here, and it's just recognizing patterns and having seen them before, but that's why I'm giving you these patterns, okay? You will have seen them before now. We kept track of our inputs. We figured out what our output should be. It's just a single output this time. They're both, the inputs are numbers, the output's a number, and our problem is summing. So we're going to have to add some stuff, and usually we'll keep track of what we're adding in some kind of variable, okay? And we came up with a process of actually doing that main problem and solving that main problem, and maybe there's a subproblem that we need to worry about also. Maybe use an if statement or an if block to know whether or not our N1 was actually bigger than N2. If so, what do we do there? How do you add from 8 to 7? That makes no sense. Okay? Maybe we just do nothing, and the sum we call the answer 0, something like that. We got to pick a rule and stick to it. So yeah, these are two worked through examples, and I specifically did not program them in Scratch because this is what needs to happen before we get to Scratch. Okay, and that is the idea. So I would really recommend that you implement both of these things. I think it would be very helpful for you. Okay, these will both take some loops. Keep doing something while something is true. Keep doing something while something is true. Stop when it's not true. So you use a while and maybe an unless. And yeah, so I really encourage that. And let's keep going. So now it's time for custom blocks. So we have all these blocks. They have been made for us by the nice people from MIT who are working on Scratch. But we are creative people. We want to work outside of the confines of these blocks. There is this button at the very bottom called Make a Block. Okay? That we can click. So the first thing I want to do is make a block that sums from 1 to n. Okay? So I'm going to make a block. It's going to take an input. I'm going to give it that n that we want to add it into. And we're going to call it, the name of our block will be sum from 1 to, and then we'll have the user supply the n. Okay? Hit OK. We now have a block. We are in a special place. So we are given a definition block. Let me zoom in after I get a sip. Okay, so this block, what it means is the code below will run with a different value of n depending on what the user entered in this block. So every single block, every sum from 1 to blank block, maybe I'll use underlines, will run the code below. It's our job to pretend, it's our job to use this n, okay? Do the correct thing each time. Okay, isn't that cool? Let me put this maybe up here. That's my comment. So everything I put under here, it will work for every single of these blocks that I make. Sum from 1 to 5 will run this with n equal to 5. Sum from 1 to 7 will run this, whatever's below here, with n equal to 7. Sum from 1 to 10 even will run this block, whatever's below it, and give back the answer. Okay? That is the idea. Okay? Sum from 1 to n. That's what we're going to do. Okay. So here's our n. We can use that. So there it is. You can drag it out. So let's do this. Let's make it so that sum from 1 to 5 does something cool. Okay? And maybe we'll have it printed out at the very end. Okay? I'm excited. Are you? So what we'll do is, I don't know, we'll make some kind of variable. We'll need a sum variable. Okay, so we're going to have to start that out at 0. And we're going to have to keep on adding 1 each time. That's what I want to do. Because, let's say we wanted to sum from 1 to 3. We're going to need to keep track of a sum somewhere, so we'll use a variable. Start at 0, as we do for things that involve plus, and then add 0, 3, 2, 1, somehow into sum. Okay? So you somehow get 1 in here, then plus 2, plus 1, then plus 2, then plus 3, and the final answer then will eventually become 4, 5, 6. So it's our job to figure out how to do that now. Okay? And we have options. So we're going to need this sum variable, and it's going to need to do something. And we can set sum to things. And we should also make a separate variable called current. Let's call it current val, I guess. And this is my idea. I don't think that there is a way to set this n that we got. So, oh, hello. It's not a normal variable, it's just whatever was given. If we run this block, n is 5, and we can't change it. If we run this block, n is 7, we can't change it. So I'm going to save n in a variable that I can change. Okay, I'll call that current val. Okay, and I'll set that equal to n. Okay, so I'll use current val as if it were n. That's the idea. So if I used this block, like I drew, that means that I will have and make my current val set to 3. Okay? And so then I can just add 3, add 2, and add 1 based on current val, and I can always subtract. And then eventually I'll get to 0, and that'll be the stopping condition. Okay? So that is, in words, my strategy. Let's see if we can implement it. Okay? So we're going to set sum to 0, current val to n. So sum is 0, current val is n. I can print them out. Let's call this current val is 3, sum is 0. So if I click this block, it's going to perform things. It's going to change current val to 7, because we set it to n, and sum to 0. Okay? If it's this one, it'll make n the 10 here, running that block by clicking it, which will set current val to 10. So every different time, every different block, we still end up here with n a separate value. Okay? So in this case, it's 10. Now it's 3. Okay? Isn't that cool? So I'm going to continuously add current val into sum, and then decrement current val. Okay? So this is going to be my idea. So I'm going to keep on saying set sum to the addition of sum and current val, and then I'm going to decrement current val, so change current val by -1. Okay, and I want to keep on doing this until the current val becomes 0, at which point I've added in every single number, right? It'll add in 3, then it'll add in 2, then it'll add in 1, and then finally there's nothing left to add once it hits 0. Okay? So, let's make this work. Whee! Where do I want to put this? Alright, so we want to repeat this. Let's use a loop to do that. So repeat until something. Sounds like a good idea. We don't want to do it forever. We don't want to do it a set number of times. Actually, we could do it a set number of times, but we're going to repeat until. And what is our stopping condition? When do we want to stop adding current val into sum? Okay, when do we want to stop doing that? And my idea is once current val becomes 0, there's nothing left to add. So that can be our stopping condition. Okay, so repeat until current val becomes 0. Until it's 0, keep on doing this. Okay, that's our stopping condition. So this will keep on setting sum to sum plus current val, changing current val. And let me walk you through this. So I'm going to say I equals 1 to 3. Okay, so current val is 3, and we're gonna do this loop ourselves by clicking this. So set sum to sum plus current val and change current val by -1. Click it. So sum is now 3, current val is now 2. We've decremented it. Do it again. It's not 0 yet. See that? Current val is 1, sum is 5, almost done. Current val is 0, sum is 6. We have the right answer, we can stop, and that's when we want to repeat until. Okay? That's why we do that. And so now, click that, or click from 1 to 3 to run it. Current val should be 0, because we're always going to end with 0, and then sum holds the correct sum. Same for this one. Current val holds 0, sum holds the correct sum. Same for this one. Current val holds 0, sum holds the correct sum. Isn't that cool? We've made a block that does the right thing. And we can make it say the answer. We know it lives in sum, so we can say the sum from, we're going to need a lot of pluses, or a lot of joins. The sum from, oh gosh, I need to put it there first. The sum from 1, 2, and then we give n space, no, sorry, then we give actual n right there, the variable, space is, oh sorry, I need another join, don't I? Is space sum. Isn't that nice? These are all hidden now. Okay, so every time we run one of these blocks, it runs this define, this entire thing, with a different value of n. It changes each time depending on the block. 1 to 3, it's 6. 1 to 7, 28. 1 to 10, 55. Isn't that awesome? So we made our own blocks. And we can keep on doing this. So I'm going to save this. Boop. And let's move on. If touching paddle bounce. So remember I was angry when I made Pong. And I was angry because when we programmed our ball to touch that paddle, it really should have bounced off that way, right? But we made it bounce off the same way it came. We made it do a 180. Whereas this is a bit more complicated. Let's make our own if touching paddle bounce block to do it the right way. Instead of, it'll be like the companion to if on edge bounce. All right, I'll make a new thing. And I'm gonna get some stuff. I'm gonna get I'll just do it quick. I'll get the paddle. And I'll get the ball. Maybe we can have the Scratch Cat be the ball. No, sorry Scratch Cat, we have to say goodbye. So I'm gonna have that turn. And I guess we should probably have it, it won't be 180 exactly. There it goes. Okay, so let's just quickly make the paddle work properly. Events, when the up arrow is pressed, we're gonna change Y by something, and then similarly when the down arrow is pressed, change Y by negative something. Let's see how this is working. Whee! There it goes. Maybe that's too slow, make it 20. How's that? Alright, that's good enough. Good enough to do what we need it to do. And then ball will have some random initial direction. Or maybe we'll just always give it a normal direction, why not? We're just doing this quick right now. This is not the point. The point is making this block. Control, events. What do I want to do? I want to give it an initial starting direction. Where's 45? Is that? Sure, 45 is fine. It'll start off being 45. And then continue as it's going. So we're going to, forever, this ball is going to move. It'll move in its current direction, but also bounce if it ever hits the edge. So let's see if that's going to work. Yeah. And then we need to program the actual paddle. So it should also, if it hits the ball, or if the ball hits the paddle, then we should do something. It needs to bounce off. Okay? So also when this is clicked, we should forever keep checking if we're touching the paddle. If so, we need to bounce off. All right. So it's going to be these two, and we're going to have to do something special in here. And I want to use our block. All right. I want to make an if touching paddle bounce. And so essentially, we're going to include this if statement, this if block, into our own custom block. So if touching paddle bounce. That is the name of our block. It doesn't need any inputs. It's just going to work, and we're going to define it now so that we can use it right here. Bounce off the paddle. Okay, and so we're going to put that there because every time this runs, it's going to run all of this. So if it's touching the paddle, then we need to do something. We can make it do the old thing right now. We can make it change its direction. Let's see, do I want to just do that? Yeah, point and direction. Direction plus 180 or something. This is the old way. And I got rid of direction. There it is. Plus 180. This is the old way that I didn't like. Let's watch it. Bounce. See, it should have gone off the other way. Same there. That looks wrong, right? So let's do it right. So this is not correct. We need to change this direction to be something different. And let's pretend we're the ball. and here's its direction. It's currently in that direction. Well, if it's coming in this way, and look at the arrow, the way it's pointing, if it's coming in this way, it needs to bounce off this way. Yeah? And if it's coming in this way, it needs to bounce off this way. It's coming in that way, straight, it's going to bounce off straight. That's the idea. Always bouncing off in that way. Yeah? Bouncing off that way, goes off in that way. And notice this direction down here. It might be too small for you to read. I'm sorry about that. But this is the idea. If it was, I don't know, negative, I wish it were snapping. It was like negative 118. We want it to bounce off. Oh. Ooh, everything paused for a second. I hope you heard that. My computer is not happy at the moment. Okay, if it's coming off at this angle, negative 90, we need to make it, we need to make it 90, positive 90. If it's coming up at us at negative 49, we need to make it bounce off at, oh shoot, 49. Ooh, we can do that. Point in direction, negative direction. What's the thing? Can I? Okay, we can just multiply. Direction times negative 1. No, go back. I want the whole thing. No. Scratch is sometimes not happy. Okay. So now, if touching paddle bounce, moment of truth, moment of truth. Oh, yes. Oh, that's how life should work. Isn't that beautiful? Save that. Alright, so the idea behind this whole thing, custom blocks, is that we are making bite-sized pieces of problems for us to solve. So we're breaking down problems into smaller blocks. And that at the end of the day makes our life so much easier. It's easier to think about that, and it makes things simpler. So we can have a bunch of little tiny blocks that do exactly what we tell them to do. Maybe they take inputs, maybe they don't. But then we just need to build up these little blocks into maybe bigger blocks there. Okay? So now we can use things at this level of abstraction. We don't have to worry about the if statements anymore. We can use this new block that we've created and think in terms of that. And that really helps us grow our programs to be large, but still correct. Okay? That is the idea. Okay, and then finally, let's make a state machine, because we learned about state machines in class and it was kind of disconnected from computation. So let's make a divisible by 5 state machine. So let's have the user enter in a number, like, I don't know, 100. If n happened to be 100, it's divisible by 5, right? But how do we know that? How do we know that? Well, the reason is the following. It's because, think back to grade school, how do you know if something's divisible by 5? You just look at the last digit, right? Well, if that's a 0 or a 5, we know it's divisible by 5. Otherwise, it's not. Okay? So just look at the last digit and have it all work out. Now, let's pretend that the user is typing the number a character at a time. And this is going to be where the state machine comes in. So we start out having not seen anything, and we're like, not divisible by 5. So we haven't seen any numbers. And then the second we see the last digit, the next digit that the user enters, if it's a 0 or a 5, then we are divisible by 5, no matter what. Just pretend that the user is at the keyboard typing in a bunch of random numbers, and the last thing that they type is the number that we want them to, that they're considering. So it's like first they type 5, then we consider, yeah, 5 is divisible by 5. Then when they type a 7, now we consider 57. No, that's not divisible by 5. And they type an 8, and now we consider 578. No, that's not divisible by 5, because the last character was not a 5. Okay, and then maybe they come around and type a 0, and these are all at separate points in time, and then we consider the whole big number, 5780. Yes, it's divisible by 5. All right, and so it's always the last character that we care about. If it's a 0 or a 5, it's always divisible by 5. So if we're already divisible by 5, and there's another thing that's added, like 55, 0, 5, no matter which character we ended on, it was still divisible by 5. And then the second we type something that's not 0 or 5, we're not divisible by 5 again. Okay? And then we'll stay in that state as long as not 0 or 5 is typed in. So I hope you understand. It'll make more sense in code, of course, but that's what I want to do there. Now, make a new project, and let's do this. Let's ask the user repeatedly to enter stuff. No, it's down here, isn't it? What is the next digit? And wait. Okay. And then we'll get answer being that digit. And so repeatedly, we want to do this. So forever. Till the end of time. Ask the user what's the next digit in the number that you're typing. And get that. Get that single digit. And if it was a 5 or a 0, well then it's divisible by 5. We actually could use an else. So delete. The whole big number that the user has been typing is divisible by 5. Okay? So we need to check that. So if the answer that the user typed into this question was 5 or a 0, then it's divisible by 5. So we know how to do 5 or 0 now. We have our OR operator. If answer is equal to 5 or answer is equal to 0. Either case, it's divisible by 0. Or divisible by 5, sorry. Otherwise, it's not. And just to drive it home, I think we can save that number as well. So make a variable called big number, and we'll just build it up. Set big number to blank, and then we'll continuously add on the digit. Join big number and answer. Okay. So now we've saved it. All right, so let's run this program. What's the next digit? Let's pretend that our user is going to type in 5780, just like that. So let's type the 5. That's the first number. And it's currently divisible by 5. Our current number is just 5. Okay? What's the next digit? Well, it's 7. Not divisible by 5, and that's the whole number, 57. Alright, next digit is 8. Still not divisible by 5, 578. But the second I add a 0, now it's divisible by 5, and the whole big number was 5780. Okay? We have just implemented a state machine. Isn't that cool? Okay, I need to get ready for your programming assignment. I need to write it up, and then I will be right back. Okay, I have returned with information on your programming assignment. This one, I'm going to give you 2 weeks to do it this time. It's a bit more in depth. So, here it is. It is actually going to be up to you. So, you can implement whatever program you would like. I've given you some requirements, though. As long as you fulfill those, you are set. All right, so please be creative. You can implement whatever you want, just include the following stuff. All right, you have to have 3 key press events somewhere in your program. So maybe you can, for example, for the Pong game, it's one of the key press events can be move up when the up key is pressed. Same for the rest. So your program must use at least 2 if-then else or if-then conditional blocks. So you need to use some kind of conditional block. For example, you can check if the ball is touching the paddle for the Pong game. And continuing with that, you must have at least 2 loop blocks, so like repeat until or forever, things like that. Move in the current direction forever is a good example of that. One thing your program cannot do is exactly copy anything that I gave in class as an exercise or an assignment or like an example. So anything that I've done in class or talked about, you cannot do any of those things. You can build on top of my examples, your previous work, as long as it's not the exact same thing, and you've added stuff and it looks cool, I think you'll get full credit. So with that, please upload a video of your program running, and I really want you to explain your code to me because I did not make up your program. Your idea is your own, so I want some extra explanation this time. So record it however. Please explain your program, how it works as you demonstrated. Show me that code, okay? Explain that code. Show it to me. I want the code to be visible. And the demonstration video should last about 2 to 3 minutes because this is different. You're going to have to explain to me your choices, how your code works, things like that. Yeah, so please explain all those things to me, and if your microphone is broken or something, just add a write-up to your video as well, so you can submit 2 files, hopefully. And that is the idea. So have fun with this one. You will have 2 weeks to do it, so yeah. Good luck. And that is where I want to leave you, so have a good rest of your week.